Hi guys, it's Clyde with PT3D. I'm having issues with my printer, and I had asked for a little bit of input last night on Dustin, the Jetman, with his Q&A last night. He was kind enough to suggest that I check my PTFE tube. Well, I did that, and wow, what a difference that makes. So the little tube liner or insert in the throat between the extruder and the hot end, yeah, that was not working the way it was supposed to. So I'm going to show how I replaced it. Whether it's right or whether it's wrong, it's the way I did it, so I apologize if it's wrong. I mean, you could certainly give me criticism, I'll take it. You ready? Let's get started.
Alright, so this is my Alunar Prusa, well they say Prusa, it's more like an ANET type machine. The hot end and extruder assembly are essentially held together by two screws, not including the J bracket. These two screws hold the fan cover, the fan, the heat sink, and that all goes through a little tiny block on the J block, whatever you want to call that thing, the bracket that goes to the linear or bearings. That all gets screwed through that little post and then into the extruder. The overall simplicity of this particular assembly is awesome and seriously inconvenient. Like you can't verify the settings of the filament once it's inside the hole on top of the extruder. So anyway, the whole purpose of this video was, as I mentioned, was having a clog or something to that effect. There was something strange going on where I would get a little bit of a layer going down, maybe about half. It was a fairly large part, and I was under extruding like mad. And as part of the extruding, I was also hearing this that popping noise from the extruder when it's trying to push filament, but it's not going anywhere. So I was getting slipping going on in that. This Jetman recommended I should check the throat assembly, the PTFE tube, and make sure that it's not malfunctioning, which we will see how that looks. And in case you're curious as to what I'm doing here, I'm trying to push some of the excess filament through the hot end. That way there's just a tiny bit in the reservoir. I'm going to fish my other filament back down in there while it's cooling off and try and nab the rest of it. That way there's nothing holding the throat and the block and all that together, because nothing is worse than after you get the heater and the thermistor out and the throat is seized into the heater block. On a side note, I'm cleaning the throat with a very, very, very small um, drill bit. I probably wouldn't recommend doing that with a new throat because it probably would scar, which would lead to rapid failure. So I'm using it on this particular situation because I didn't care. I was just trying to get as much filament out, and having the drill bit allows some of the filament to get caught into the grooves as it cools down, and I can pull some more out. And as you saw with the filament there, I was able to get a little bit of extra out of the end. And this is the socket that I use to remove the tip. Now, when I bought this kit, it came with this particular crescent wrench, which is actually really handy. It doesn't work for the nozzle, but it does work for the nut that holds my throat, heater block, and nozzle into the extruder block, or the J housing there. And right now what I'm doing is loosening up the set screws for the thermistor and the heater block. Keep in mind I'm also working on a still cooling hot end, so I'm trying not to burn my hands when I pull the heater out. The reason I'm doing this, like I said, is because I don't want to have the block too cool and I don't want to have to reheat it after. It's just a lot of wasted time, so I'm working with everything hot. So I was trying to be very careful to keep the heater and the thermistor off to the side, but the power is turned off at this point. And I'm using the pliers just to kind of spin it out so I'm not burning my fingers. At this point, it's probably just about cool enough to the touch to like handle. But the problem is the nozzle and the heater block stay hot for about a minute or so, like to the point that you might be able to burn yourself. I think I was ramping the temperature down from 208 degrees Celsius on this, which is just about ABS temperature. But for whatever reason, I've been having to run at about 210 for some of my PLA filament, which does not seem natural. So I don't know if there's a inconsistency between my thermistor and my heater, or if for some reason I'm running it too hot. But it's the best temperature that I have run things at, and I've been getting pretty good layers up until this point. But I am wondering if the higher temperature is causing my PTFE tube to wear out quicker. Because if you, I mean, I didn't realize that the focus was not working in this point. And again, there's my little drill bit. But if you were able to see it, if I was pointing it in the right direction, you'd see the tube is definitely out of round, which means that at some point it's kind of moving or not lined up exactly correct, which could be causing some like small amount of filament to get stuck, maybe. But either way, the tube was definitely damaged. So, and I'm trying to point out there's a little divot that you want to have pointing up so the filament slides into it. Um, this allows the PTFE to be open at the bottom of this particular style throat, and it allows you to back your nozzle into it. So basically, you thread the throat into the block, and then you get it probably a little best halfway or so, depending on the depth of the threads on your nozzle and how you have it set. Then you want to take your nozzle and you want to screw that into the heater block on the other side so it tightens into the throat. You got to be careful when you do it. You don't want to over tighten it because something will break. But when you tighten the nozzle into the throat inside the heater block, it guarantees a seal. If you bottom out the tip, you don't know if you got a seal or not. So it's best to tighten the tip into the throat and just leave it like that. When you're disassembling the throat from the other heater block or one that you've been using, sometimes the throat gets stuck into the block. It can be very helpful to have a second nut. That way you can tighten them together and you can turn them slowly out of the block. So I have one spare nut that I have just for that purpose. Or if for some reason one gets stuck on another throat, then I can just replace the other one on the new one. Because most of the time, I don't get a replacement nut with the throats, tips, heater blocks, and stuff like that, or the full assemblies that I order. That includes the heater and thermistor assemblies. I don't think I can express again how important what's coming up is. One of the biggest things that happens when you're first getting into 3D printing is fixing your first breakdown. A lot of the times, the breakdown can happen with a thermistor, for example, just because I know that's a really good example, and they have a tendency to fail. Um, when first off, with the hot end, the tip, heater block, and all that, make sure that you snug it, but don't reef on it, because if you do that, things are going to break. Just a little bit of pressure, a little bit more than hand tight, like a tool tightness. When you're working on the heater block and putting the heater and the thermistor in, the most important thing you can do is use the finger tight method. You have to use an Allen wrench to tighten a set screw, but you want to make sure when you're putting that thermistor in, depending on whether you have the brass covered bulb or whether you have the straight bulb, that you're not tightening that thing more than hand tight or finger tight. I mean, I'm talking just a small amount of pressure on that thing, just enough to keep it in there and not for it to back out on you, but not so tight that you just blow up the bulb. One of the biggest things I've seen happen is people shatter the thermistor. And what's funny is sometimes they will still work, but they may not work all the time. So like once the block heats up, it might stop working, so you're going to get erratic temperatures, which is really going to mess up your printer. Not to mention the fact that you could end up with just slag. And if you're printing with ABS, you could, in theory, cause a fire, but I haven't seen it actually happen. Mostly it just turns into this burnt black sludge nastiness. So I can't tell you how important it is to be extremely careful when you're tightening your thermistor set screw. The heater is a much more resilient thing, but again, you want to keep it tighter than the thermistor, but not so tight that you somehow manage to punch a hole through the side of it, which I haven't seen done, especially with the blunt set screws. But again, you don't want to push the issue on that or the envelope, so to speak. So this part that I'm doing right here, I may make it look a little awkward. This thing is a pain in the butt to put back together because of the front spring. This is the only machine I have ever worked on, so I don't know if this is the case for all machines. It seems like a very simple, like I said, but inefficient design. Well, I guess efficient is a relative term. Efficient as in the minimum amount of use of parts. The lack of efficiency would be the amount of time it takes to put it back together. You'd think that less parts means quicker assembly, but in this case, you have to kind of fudge with a little bit, get the holes and everything to line up because it's going through the cover or the shroud, it's going through the fan, it's going through the heater block, through the spacer block or the mounting block, and then into the extruder. And those extruders, those holes, they're not tapered, they're flat. So you have to make sure that you get everything in a row. So you got about an inch and a quarter worth of stuff that needs to be nice and lined up. And you're still trying to hold your gantry so you're not racking yourself as you're going. So a little bit of a pain, but definitely doable. And I know I haven't mentioned it, but if you haven't noticed, that fan is completely blown out. My cooling fan for my prints. It's been blown for a little over a month now, and I have a replacement on order. I apparently chose the wrong vendor because it's still not here yet. On this part, I just wanted to show the kind of display that I use. Again, this is the only 3D printer I've ever used. This is the only one I've ever assembled. This is my first and only 3D printer that I have right now, although I do have another one on order. And so right now what I'm doing is I'm just kind of moving my gantry around a little bit. And I am going to be homing this so I can do the bed leveling sequence. I touched on this before in a previous video, but I don't think I went into quite as much detail as this because my camera stopped working. It wasn't recording, so I had a whole lot of wasted time talking and a whole lot of nothing happening. If you ever do decide to get one of these printers like this, from what I've been told, the ANET A8 works wonderfully. And you can visit the 3D Maker Noob on his YouTube channel as well. And Joe does a really good job talking about the ANET A8. And you get to watch his assembly video, which is fun. Although I don't believe he called it the ANET A8. Okay, yeah, he called it the Tronxy P802MA, which is an ANET A8 clone. And as I'm leveling this, I have learned that using a piece of paper doesn't always work. What I do is I use something like an index card thickness. It's a little thicker than a regular piece of paper. And I do that because when I push it, if I feel it bump into the tip, I know that I have enough room to raise my bed to calibrate it better. So I prefer to calibrate mine as it's moving because I have a warped bed. So once I get a good layer thickness that makes me happy, I leave it alone. So this is just my preliminary part of my bed leveling. I'm just, sliding the card in, seeing if I'm hitting it. I know that you'll probably hear a million and one people tell you how to level your bed. Um, you're going to have to just experience it. There's no hard and fast rule other than using a feeler gauge. But on a bed like mine, it's not just the springs that move, it's the bed itself. So if I push in a piece of paper too hard, the bed will actually get out of the way. But the linear bearings and the gantry are also loose. So I've got several millimeters of play between the build plate and the gantry where the heat or the extruder end is that will move around. So I have to just kind of slide just real easy until I just barely feel a little bit of resistance and I know that the card is making contact with the tip. I'm hoping that that made sense. Again, I completely encourage you to leave me criticism if you see anything that I need to improve on. I do know that my printer is a mess. As you can see, I 3D printed some spacers that I have towards the top of my Z-axis guide rails. The point in those is originally I was trying to find a faster way to ensure that my gantry is square. This was before I have the current build plate I have now, or not build plate, sorry, the workbench I have, which is level, like all the way across. So I know that that's level, so I've actually been using a bubble level to level my gantry and my build platform. You're not going to see me do that on this, I don't think. Pretty sure not. And that's because at this point it's already pretty close to that. I'm just having to raise a little bit to accommodate for the new adjustment on the tip because I never managed to get my tip to be in exactly the same spot every time. I'm getting better at it, but it's still, eh. I'm trying to think. Also, on the bottom left, there's a pressure switch, or my end stop switch for my Z, that's mounted behind the guide rail for the Z axis. That thing is a pain. It's got a couple of screws that hold it in place. You loosen them up, you lift the bracket up just a tiny bit, or you bring it down just a tiny bit, and that's how I get my gantry close to what my build plate is. That way I can adjust my build plate accordingly. I always recommend when you're adjusting your build plate, adjust up. Don't adjust down, always adjust up. Eventually you'll have to bring the build plate back down and start over again, but you always want to bring the build plate up to the nozzle. You don't want to do it the other way around because then you run the risk of running out of tension space, like if you're using a spring system. And if that happens and your gantry for whatever reason gets out of alignment, that nozzle is going to plow into your bed and it's going to tear it up. And I don't care how much tape you have on there or what your build material is, but if that gantry comes in at an angle just right, it's going to actually damage your build plate and it'll probably do some damage to your hot end. I'm bringing up the Z-axis at this point just so you can get a better view when I start pulling some of the filament through. It's kind of difficult for me to actually feed the filament into the extruder on this machine because it doesn't, for whatever reason, line straight up. There's a slight variance to the way the blocks are lined up. And unfortunately, that means that I have to kind of, you know, twist and bend the filament around a little bit, which I'm not really showing. Um, the extrusion isn't coming straight down. It's kind of curling around the nozzle. So that's another strange thing that's been happening. I don't know if this is filament related, temperature related, or what, but the filament should be coming straight down and it's not. Alright, we're back to the second way of leveling your bed that I had discussed in my previous video, which is doing what I call the live leveling, which is leveling the bed while it's running. The first pass on my brim actually looks pretty good. I mean, I could tell from this camera angle that there is a little bit of a shallowness to the upper right corner, and looks like the bottom right corner could be adjusted a little bit. So basically my right side of my bed is just a little bit too low, and I gotta bring it up just a touch. And top left, if you're looking at it, does look like it's a little bit close and it could probably go down a little. But if you also look just a little bit farther down on the left, because it's warped, it's actually not a good idea for me to adjust it any further. So anyway, that's how I do the live leveling. Appreciate you guys watching. I hope you got some kind of information out of this, and I look forward to talking to you guys again soon.